The result is still returned in around 10 seconds. It's amazingly performance. It only takes 10 seconds to figure out if a number's even or not. This is so good. 4 billion if statements. I recently stumbled upon this screenshot while researching social media on the train. I hate that I use classical here because I'm a music person. It's going to f*** my brain. I'm just going to make my brain work. Fixed. Criticizing the fresh programmer's attempt to solve a classic problem in computer science, the modulus operation. You know it's going to be good when it's not a screenshot, it's a picture or like a moment from TikTok like that. That's when you know we're going down a good path. Now, in a world where AI is replacing programmers by the minute, taking their jobs and revolutionizing the way we think about code, maybe we should be more open to the thought of the fresh new blood of the industry. In fact, the above code is a perfect example of a time-memory trade-off. You're trading off your time, and at the same time, the computer's memory and time as well. Truly a marvelous algorithm. You didn't read it yet. It's an even odd where every number is listed. If the number is this, even odd. And joking that this is an ideal trade-off because it's giving up both the time and the memory for no reason. Love it. So I went to explore the idea of checking if a number is odd or even by only using comparisons to see how well it works in real-world scenarios. Since I'm a great believer in performant code, I decided to implement this in the C programming language, as it's by far the fastest language on the planet to this day, thanks to the visionary genius Dennis Ritchie. Starting to get an idea of the tone of this article, and it's very entertaining. So I started composing. A bunch of your classic includes. Now we have int main, if number is 0, even, if number is 1, print odd, down to 10. Cool. Let's compile the code, disabling optimizations to make sure the pesky compiler doesn't interfere with our algorithm. After compiling, we can do a quick test of the program and we get some positive results. Nope, positive. He's not handling negative cases. Anyways. However, after doing some further testing, I found some problems. When you have numbers that are too big, you don't get a response. No output. It seems the program only works for numbers under 11. Going back to the code, we can find that the issue is right after the last if statement. We need more if statements. Now, this is a time-memory trade-off. My time on this earth is limited, so I decided to meta-program the if statements using a programmer program in a different programming language. To compensate for this cheating, I decided to use the slowest language on the planet, Python, thanks to the visionary genius of Ross van der Grussem. The slowest is a statement, but fair. Now we have print statements for the comment at the top. Print includes this. I'm loving every second of this. For I in range 2 to the power of 8, print. And I love this. So this is the correct code. He meta-programmed the right answer to write the code of the wrong answer for him. That is beautiful. I love where this is going. Nice. Now we can generate a program that solves the even-odd program for all 8-bit integers. It worked. He piped the output to program.c, compiled it, and it worked. It's a small thing, but I also love that he's using Windows for this. It's just such a nice little unnecessary additional detail that adds a special layer of chaos. And I hope we hit file size limits because Windows handles those so poorly. Let's see where we're going. Would you look at that? It works flawlessly. Now let's scale it up to 16-bit. Change this to be 2 to the power of 16. This gives us a nice and thick C file of around 130,000 lines. Nothing really when looking back at some of the code bases I've worked on over the years. Let's compile. Look at that, it worked. Our algorithm seems to scale with the data. The execution's around 2 megabytes, but that's no match for the beefy gaming rig I have with a whopping 31.8 gigs of memory. 16 bits a very cool bit width. That's such a statement. 16 bits of very cool bit width. Sentences that have never been said before. This article is going to have so many unique sentences, and I love that about it. But as we all know, 32-bit is the holy grail of computing and is the final bit width that we need to solve all practical engineering and scientific problems. You're starting to sound like a certain holy C programmer here when you say there's a holy value. And I'm pretty sure it was 16-bit, but we'll take it. 32-bit seems like a good place to cut off. 64-bit, no one needs that. No one really needs that. Come on. Have you ever really used 64-bit number? Name one 64-bit value. I dare you. Leave one in the comments if you have one. After all, IPv4 is still standing stronger than ever 60 years after it was deemed deprecated due to so-called address exhaustion, which is, funny enough, another topic that's been coming up lately. I might have to do an actual IPv4 video, which I certainly didn't think 10 years ago when the IPv4 drama really started ramping up, that 10 years later, I would be a popular YouTuber that felt obligated to talk about IPv4 in a video because it still hadn't been solved. But here we are. So without further ado, let's scale to our final size. 32-bit is only 65,536 times as many numbers as 16-bit. So what could go wrong? Oh boy. So let the mighty snake do its work. And after getting a cup of coffee and getting back to check on this program 48 hours later, I was left with a beautiful C file, almost 330 gigabytes in size. I promise very few of you have experience dealing with files over 100 gigabytes at all, much less in Windows. I'd say 50% chance that Explorer EXE just crashes when you right-click on that file, like it does for my giant MOVs when I'm done recording my videos. Oh, God. Almost certainly amongst the largest C files in history. God, I hope so. I hope that you're at least in the top 50. My fingers were trembling when I entered the next command. Surely MSVC had never before encountered such a powerful source code. After abusing the page file of my poor, powerful computer for half an hour, the following was spat out. I don't even want to think about dealing with paging in Windows to convince that something was in RAM when it's not, so you could do this. Oh boy. Warning, compiler limit, terminating line number omission. Compiler limit for line number, 16,777,215. That's the limit for number of lines in the C compiler. Pathetic. And not only did the computer fail us, when looking into the limits of the portable execution format, .exe, for Windows, I discovered that it cannot handle more than a measly 4 gigs. With more than 4 billion comparisons needed to be encoded in that executable, this is a major obstacle for implementing our algorithm. Even if each comparison would use less than a single byte, we would still be too heavy. However, bad compilers and file formats should not stop us from achieving our dream. After all what a compiler does is write some fancy machine code in a file, and the file format is just some structure telling the OS how to put the binary code into memory. Really, we can do that ourselves. Let's start by writing an is-even function in x86-64 assembly, as it's the native language of my Intel-powered machine. Why are we into assembly now? How does this is such a ramp up. This is incredible. It looks something like this. I don't know if y'all have the same trauma I have around assembly, but one of the worst classes I took in university was obviously poorly taught, and the final project was writing an assembly MIPS compiler and runtime. So I would take MIPS assembly and run it in my own C++ code, and it was hell. And as soon as I see this, specifically in this context, straight pain. And again, this is an is-even function, is this much code. I hope you all understand just how crazy the assembly underneath your JavaScript functions can get, because it is not fun. So we set EAX to 0, which is where the argument is, and then the EAX is the return. So we set it to 0. We compare that value with 0. We skip to the next 2 instructions if it wasn't equal. Otherwise, we increment, and then we return. But since we skip 2 lines otherwise, we go here. We compare it to 1. If that's not correct, we skip again. If that is true, we return. Otherwise, we go here. Add the next 2 to the 32 comparisons here. Cool. So yeah, it checked 0. It returns if it was good. It jumps if it's not. It checks 1. It jumps if it's good. It returns if it's not. Just that over and over again. Not really correct assembly. That doesn't matter much because we're going to compile it into machine code manually. How did I do this? Well, I jumped online using a mix of my early life experience coding emulators and hacking, and I looked into the x86-64 architecture manuals to find out the correct opcodes and format for each instruction. Just kidding. That's horrible. I asked ChatGPT what the correct opcode was for each instruction, and lucky for us, it didn't hallucinate any new extensions to x86-64. Honestly, in 10 to 30 years, people are going to look at the x86-64 standard and just assume AI invented all of the pipes because they make no fucking sense. I could rant for a long time about x86-64. That's not what we're here to do, though. We're here to see it being abused. So let's take a look at this abuse. So now we just write a compiler to output this code. Note that we will write the opcodes we got from the AI for the instructions directly. Here's how it looks in our friend Python. They have to escape so much shit. This is going to be terrible. With open is even.bin, write permissions as file, file.write, Lazor, for this range, encode. Oh God. Oh God, I hate this so much. While we somewhat deviated from the original vision of the TikTok post, the essence remains the same. We created a long list of if statements to determine if any number is even or odd, ignoring any arithmetic operation that would help out. Running this gives us a nice 40 gigabyte file, which contains all 4.2 billion comparisons needed to determine if any 32-bit number is even or odd. Now we just need to write our host program that can load and use these instructions. For added performance, it is very important. I decided to map the file into the address space instead of reading all of it. By doing this, we can just pretend that the entire file is already in memory and let the poor OS deal with fitting a 40 gigabyte blob into virtual RAM. After mapping the file with read and execute permissions, we can call into the code by using a function pointer. It looks like this. So we're still using some C++ just to call this bin. Handle bin create, interesting. Open code file, get 64-bit size of file, create memory map of the file, get a pointer to the code, create a function that points to the code. And there we go. Now we have everything to check if any 32-bit number is even or odd. No shit. He actually did it. Oh wait, I got one wrong. Almost. Seems like the algorithm has some issues with signedness. Any value over 2 to the 31 seems to give random results. Sad. Let's fix the bug. Right now, we're running into the problem where after you have mapped the 40 plus gig bin file, you have to get this to run inside of C++. Once you've gotten a pointer, you can then create a function that reads over that to execute instructions. And then you can actually figure out if a number is even or not. Finally, this is all the work we've had to do just to know if numbers are even or odd. Sadly, this didn't work, though, to catch you up, because any value over 2 to the power of 31 gives random results because of signedness. So let's figure out how this gets fixed. It turns out that A to I cannot deal with unsigned pureness, so it fails to parse our big boy numbers. Replacing it with string, I don't even know how to pronounce this particular C function, fixes everything. Cool, no problems here. Oh, look at that. It's working again. I thought that was going to be a scarier fix. Unsigned long. Oh yeah, string to unsigned long. That's what that is. Thank you for the translation from C to English. Quick chat credit, down low thing, and Backman. Thank you both. Yeah, only 40 gigs. A shame you optimized the complexity from the over 300 it was prior. Anyways, as a side note, this program is amazingly performant. For small numbers, the results are instantaneous, and for large numbers, close to the 2 to the 32 limit. Huge props to the author. Considering the computer has to read 40 gigabytes of data from disk, map it to physical memory, and then let the CPU have a rip of it without many chances of caching is honestly quite mind-blowing. Yeah, imagine showing a dev from like 20 plus years ago or back in like the single core era this code and telling him it only takes 10 seconds to figure out if a number is even. Just the amount of different feelings they would have in that moment. Because I'm having at least a few of those feelings right now. And I already know that there's something better than x86. I can't imagine how they felt back then. For reference, the computer's a Core i5 12600K with 32 gigs of RAM, and the files are reading off an M2 SSD disk. While calculating, the peak read speed I saw from the SSD was around 800 megabytes per second, which doesn't really make sense, as that should give execution speeds at 40 plus seconds, but computers are magical, so who knows what's going on. The ways operating systems handle files is weird. Anyways, and there we have it. The internet proven wrong once again. Not only can you actually write a fully functioning and performant program in the manner of that TikTok post, it's also very fun. Yeah, that was absolutely hilarious. Huge shout out to Andreas for this awesome blog post. Sadly, he is not on Twitter, and I don't really know what else to shout out of his. The URL for this post will absolutely be in the description, so check that out if you haven't already. That's his only blog post. That's impressive. For this to make a blog just to make this post, incredible. A++. I am thankful I stumbled on this blog post. I guess that this is how you fit 4 billion if statements into a single program. If you want to see something a little less chaotic, like, I don't know, running JavaScript at a native level by compiling your JS to assembly, I actually have a video about that for some reason. So check that out if you haven't. Otherwise, watch whatever's below it. Appreciate y'all a ton as always. See you in the next one. Peace, nerds.